starting from lecture 3, then data wrangling in R, cheat sheet, data visualization cheat sheet, and then importing CSV files into R, and then some files, etc. So when you click on one file, you will be able to see the HTML version of it like this, and then you can easily refer to the code. Okay, so like first of all, let me see what we can do here. So if you click on, so in my computer I have these files, so I will start from lecture 3, that is this one, lecture 3. If you click on this one, you can see an HTML file with all the codes and respective outcomes for the lecture 3, and then from there onwards I will work into the rest of the things, right? So let me open R. Right. So let me open the file. I think, okay. So this is the RMD code. I will run along with that. Okay. So this is the lecture that you will see here in the Moodle. So lecture 3. Today we will be learning about the types of data and the visualization that we can make from that, those type of different data, and then we'll move on to important factor about importing data from different sources, like importing CSV files, importing Excel files, and some work on gather and spread in R. And then we will talk about converting data types in R. So first of all, let us start with the lecture 3. When you have installed R Studio, you automatically have this function called function, or rather the library called datasets. So we'll import that one. So for those who are not running from the script, what you can do here, I'll open the terminal. So I'll clean it up, Control L. So it will clean my console. Once you clean the console, it will look like this. So you have to import the library. So the name of the library is datasets. So we have inbuilt thing called dataset. Let's see. Right. So it is there. You can't see it as the environment is empty, but when we like kind of say what we want to know, question mark datasets. So it will show us what it is. You can see what it is here. The R dataset package. It's a base R dataset, and this package contains variety of datasets for exemplary list. We'll go here with library help datasets. You can go and see that. So it shows us what do we have here. We have air passengers, BJ cells, BOD, CO2, this chick weight thing. We'll learn a lot about this data. We'll use this data set to learn some facts about the visualization, data visualization. And we'll also look into some of the things related to different types of data visualization here in R. And then you have inspect, Nile, and etc. So here, what we will be looking at is the data set called Iris. So I will go and type Iris. I think you might have seen this one already. A lot of lecturers and people who are learning R tend to use Iris data set. Let's look at the content of Iris. You can say, clean up the console. I'll type Control L and say question mark Iris, and let's see what it is. So you have this description here. It's very important to know your data set before you analyze it, because then only you will know what sort of techniques that you can use in order to analyze the data set. So let's look at the data set here. This is Fisher's or Anderson Iris data set. Gives the measurements in centimeters of the variables sepal length and width, and petal length and width respectively, for 50 flowers from each of 3 species of iris. So you got 3 species of iris, and then some information about that. The species are Iris setosa, versicolor, and virginica. So format, how it is being given. So for instance, this if you type Iris directly, you will get a set of data set. Now, in order to look into the data set, let's create a data frame. So I'm going to put data frame, just the type data frame, and option dash in Mac, in PC or Windows, alt dash. So that is the data frame I'm going to use, the df. I'm going to put iris there. So you can see that there is a df created here, a data frame. So if you click on that one, you can see sepal length, sepal width, petal length, petal width, etc. So the same description was available here, and you can see that. Now, how do we create, for example, let's say, if you want to see one column only, you can type df and the dollar mark, sepal length, and you can get the respective details here. And you can get this head df if you type head df. Let me clear this, control L. If you type head df, so df is the variable that we have created, that's the data frame. When we type head df, what we get is the first six, actually first five, 1, 2, 3, 4, 5, 6, first 6 data entries of that data frame. So you get the sepal length, sepal width as a data set. Okay, so this is the outcome of that operation. Now let's try to create a histogram for sepal width, right? So if you want, like for example, what is a histogram? Histogram is the frequency diagram of something. Now if I say hist df, let's see what will happen. If I say this, x must be numeric because there has to be some sort of a value. So I'm going to type df is a data frame, so I'm going to refer to a column. Now say that I want to create the histogram of the sepal length. I can go and type the dollar mark and then pick sepal length, enter. So here you will see that chart. So I can extend that here. If you zoom in, you can see how it would look like in your computer. If you can zoom in or extend it, you can see. Now here, look closely. When I type hist, I typed hist df, right? So when I typed it, it has created the histogram, and it contains this on top of the chart. You have the title of the chart, histogram of def, that is data frame sepal length, and x-axis contains sepal length df as a dollar mark sign, and then you get the frequency here. Now this is kind of crude representation of what our data looks like. So if you want to have a more elaborated version of this one, or more clean version of this, you can start editing this part. So I have given you the code, so we can start typing main as the histogram of the sepal width. So that is going to be the name of it. So if I include this part here, you can type if you go here and say comma, main is histogram sepal width. So you can see that it changed here, histogram of sepal width, right? So if you go here, histogram sepal width. Now if I want to change a little bit more on this one, if I want to change the x label, that is this df sepal length, if I want to change that, I can type xlab, that means x label, that is equal to, I can say sepal length, and I can write down the units as well. So the units going to be in centimeters. So when I type it, you can say, you can see sepal length in centimeters here. Now that is all good. Now if I want to have now since I have the entire code, I can even go and check instead of sepal length, if I want to have say sepal petal length, then I'm going to just type it there, and then can go here and just edit on those things, petal length, and say enter. As you can see that there is a histogram for the petal length. Okay, so what is the importance of visualizing data in data wrangling is that you can actually see the facets of the problem. For example, if you look at this one, you can see that the petal length, and let me close this one. Yes, and can close this one as well. Yes, right. So let me create a new plot, entire new one. You can see the petal length contains two modes. You can say modes or means. In this case, it's modes. you can have one mode here, then there's another mode here. So we call this type of data distributions bimodal, because bimodal distributions contain two modes. You can have multimodal distributions. When you visualize the data only, you will be able to see that. So that is why it's important to visualize the data in the first go. So refer to your code here and come to this point, and then try visualizing for other things as well, and take a note of what are the things you get. For example, you can even try what sort of a histogram will you create when you try doing this. What sort of a histogram will you get when you do the species, and try and just try and send me a print screen of what you have got for species. Try doing the histogram for species and see what you'll get. It'll give you like 5 minutes. Try doing the first set of codes here until the histogram. So if you have done that, just say thumbs up or something so that I can see. Once you do that, just press thumbs up. Can you hear me? Hello, can you hear me? Hello, hello. Okay. I'm at the university, so some power loss is here. So let's see. Right, have you finished that? Have you done the first part of the lecture 3 note? Come on, say yes or no, something so that I can know. Okay, right. Okay, so once that is done, you have another thing about this assigning data. So there's this code called rm list equals ls. So that's basically clearing up the code. Not only the code, it's about actually cleaning the variable. So you have a df here. When I enter that code, this means remove the list, and the whole thing will be removed. And I enter, so everything is gone. There is no environment variable here. Right. So the next thing about this is about assigning data. So I think you are familiar with assigning data, but since we are going to convert and import data from different sources today, let us kind of get an idea about how to do that. So assigning data, the easiest way to assign the data I have already shown you is doing this assignment task. Say if you want to assign a variable to XOA, here just type option dash, and then if you say 5 or something, then you can see values are added here. Okay, so when we assign that, you can get it revealed when you say like this, you can get it. And the other assignments, like these are the assignments that is interesting. One is about the assigning variables from one end to the other. So left to right, always the assignment goes from left to right. So if I go from other way around, it goes from left side to the right side. So let's say if I type 23 to 29 or something, then it goes from starting point to the end point. So if I type here 29 to 17, so it automatically sees the left side is greater than the right side. So it goes from left to right in the descending order. 29, 28, likewise it goes in the other way around. And for other uses of this, you can use the sequence command, sequence of 10, you can get that. And then let's see whether there is another variable attached to that. So you can see sequence from what to what. So if you go sequence from 10 to 5, you can see 10 to 5. Sequence from say 13 to 34. So you can see, depending on the way that you type you want the sequence, it will create the sequence. And you have this by command, by -3 or something. That this is interesting. Like 13 to 4, if I say by equals -3, you can see it goes up to 4, 13, 10, 7, 4. And if I say by -2, it only comes up to 5 only, because it doesn't have the capacity to go beyond 4. So in that cases, the sequence bounds are there, but the number that you want it to reduce will affect that. So try that out. You can try that by your own. Try to do this in your own way. You can use different types of sequences. Maybe try doing, like when I say try, just try doing things 1.5. You can do anything, like see how it actually gives you the results. So then only you will learn. Otherwise, there is no point. Give some numbers and see how the sequence works. Okay, so right. The next thing is talking about some of the math operations. Right, I'm going to control L and some math operations. So I'll start with brackets, this thing. Now, you might have noticed that when I type it like this, say I type like this, it just take the variable as is, right? So next, if I want to visualize the variable, you can just type it like that, and then only the variable will be visible to your console. But if you type the same thing within the brackets, you can easily get the values directly from 5, 1, 0, 10. It will automatically give you the variables. So if you want to check what your math operations are doing, you can do and cover that with the bracket. So if I say assign number 10, then automatically you will see the outcome. Okay, so just you can do that with the brackets. And the next thing is about creating, this is a vector using vector form. So I'm going now look at the values here. I have a y variable with number sequence starting from 5 to 10, or rather 5, 1, 0, 10, four numbers. And I'm creating a similar one with x here. So x will become 1, 2, 5, 9 here. But a stands as a single value. A is just 10. When I want to do the math operation on variables, let's see what we get. If I say x plus a, you can see that each variable in each value in the vector x gets added with a. So a is 10, and this is 1, 2, 5, 9. It becomes 11, 12, 15, and 19, right? So I'm going to revert it back to the same x. Now, if I go and type x plus y, you can see any value in the vector y will be added to the x vector as a one-to-one operation. So 5 plus 1 is 6, 1 plus 2 is 3, 0 plus 5 is 5, 10 plus 9 is 19. And let's see if we change the x vector. Now I have only 3 values next. And let's see whether we can do the operation. You can't. So because you don't have that one-to-one mapping, therefore you can't add the values because you have only 3 values of x to add to 4 values of y. So just try that out and see how you cope with it. So in order to add values like in matrices, you need to have them on the same sizes. So this is 1 times 4, 1 by 4, 1 by 4. Both have to be in that way. And let's see whether multiplication works. So x times y will give you values multiplied in terms of 1 to 1. So 1 times 5, 5, 2 times 1, 1, 5 times 0, 0, 9 times 10, 90. And if we say this is, let's say we make this one number. So you've got 3 values for x. Let's see whether we can multiply. No, we can't do that, right? So when we define the values, let's see whether we can define it in terms of lists. So I'm going to create a list of values. I'm going to check whether that's going to work. Let's see. Yes, it doesn't work. So these are the things you should try. Try and do these things in order to find out whether there is actually way to operate it like that, right? Okay, so with that, multiplication is simple. So x to the power, if you have worked with Excel, you know that you can create powers by typing this symbol. You can type this symbol by pressing shift and number 6 in US keyboard. So any keyboard with numerics will get shift number 6 will give you this symbol. So if you press that, 2 to the power 3 is 8. So if you type any value like say 2 to the power 2 is 4. So the same thing applies for other values as well. So if I say x to the power 2, you can see that it's 125. So to the power 2, it's going to be 1, 4, and 25. So it's 1, 4, and 25. Let's see whether we can do powers like this. X to the power y. No, you can't do that. So let's see whether if we change the size of x to, okay, can you hear me? Can you hear me? Yes or no? Okay, thank you. I'm
Yes,
at,
sir, we can hear you.
okay, thank you. I'm at university, so sometimes this Wi-Fi connection drops. So let me share my screen back. So right, let's see whether we can whether we can change the value, change this to x with 4 values, and let's see whether the power works now. As you can see, it works in an awkward way. Let me see. Let me see. Got 3 powers, so that has to be something. So I'm interested in that. Let's see x. If we put x1 2, and if we put y equal to say 3 and 4. Okay, let's see whether x to the power y, what kind of a result it will bring. So as you can see, it gives us 1 to the power 3 and 2 to the power 4. So 2 to the power 4 is 16. 1 to the power 3 is still 1. So that's really interesting. You can have like one-to-one mapping for powers as well. And if you want to have like sequence of powers, like for example, I'm going to do an interesting thing here now. If I want to create a sequence of powers, say I'm going to create x as a sequence of 1 to 5, okay, and then you get 1 2 3 4 5. And then let's say that I'm going to create y as a sequence of 1 to 5, right? So I got 1 2 3 4 5. And if I say x to the power y, I get the powers of respective thing, like what will be the 1 to the power 1, 2 to the power 2, 3 to the power 3, 4 to the power 4, and 5 to the power 5. So it's quite interesting. If you change the size of it, it will not work because you don't have that one-to-one mapping. So you get the error message, right? So that's about the powers. Then you have the square root. So let us see whether we can get square root of x to the x. So as you can see, it gives us the full length of it, like square root for each value. So if I say square root of 64, we should get 8. If we say square root of 64.3, 8 point some value, and we get 6 decimal points as the answer. So 6 decimal points. We can increase this one. I think you need to type something. I forgot. So let's say we can try this out by it's a sequence of 5, and if I want to get the square root of x to the power y, so you get this. So that's quite interesting. 1 and 2 remains the same, but 3 to the power 3, remember? So 3 to the power 3 is 27, and then 4 to the power 4, 4 to the power 4, and the square root of that is 16. That's quite interesting. Then 5 to the power 5, square root of that is here. So you will get a test from this, like what are these, each of these codes will do. Like for example, if I say in R, if you type like this, what do we get? So you should be able to identify what are the things you will be getting. For example, if I type square root x to the power y, and then I say sequence 1 to 10 to 3 by -2. So you should be able to say whether it's an error or not, because here sequence 10 to 3 by -2 will not be enough to get, because you need to have 4 numbers, right? So there will be great amount of numbers, 10 7 10 8 6 4. So only 4 numbers. You need to have 5 numbers. So if I say -1, again there will be more numbers. So if I say sequence 1 to 5, so it will work. So likewise, so you can see that you have 3 different options. You should be able to say whether it's going to work or not. So this is your mid-exam, sort of, not mid-exam, but quiz. In the quiz, we will be learning, or rather answering what each code would bring us, whether it is going to be an error, whether it's going to be an answer that you know. Like for example, you'll get what would this code would do. So the question will be, what is the outcome of this code? There will be like 4 options. You should be able to pick. So if it is this, that is correct. So if I ask what is the outcome of this, you should be able to tell that there is an error. So likewise, you have to be a bit careful and bit aware of what you are doing. Okay, right. So logarithmic values, with log values we will end this lecture, I mean the first part of the lecture. So if I say log 10, you will get this. But if I take log 10, 10, you'll get 1. So this log is ln. That's a natural logarithmic function of a value. So what is natural logarithmic? I think you have learned this one. It is ln or e to the e is 2.73 something. So if I try to get it, think it is 2.3 something, pretty close to 1, right? 2.731. Yeah, so E goes like 2.731 something. So that's one. So ln is the power. The ln is basically that base. So 2.714 is it? Forgot. Very close. 2.713, something closer to that. So if I, it's going to work. Yeah. So that's it. ln and log 10. If you want to get that same thing to the power to the 10, you get this, and if you 10, that is going to be 1, right? Okay. So try that out. Try the log part as well. Just try doing that, exploring sequences here, and after that we will move to the next part of the lecture. So this is first part. You can, by the way, you can easily download this. This is there. I prepared this one for you. It's there already in the Moodle. And there's the other lecture note. It's the cheat sheet. Then there are, after the cheat sheets, you will find importing CSV files into R, importing Excel files into R, and gather and spread. I'll after this lecture 3 code, I'll move to the converting data types in R, and then I'll go to gather and spread. Then we'll see. So give me a moment. All right. Okay, so next one, I'm going to clean this. Next one is converting data types. So let's say that we have a vector of numbers representing the number of hole shots. It's like it's basketball. It's like similar to netball. If you are familiar with netball, it's just going and just putting the ball over a ring. So the number of 4 shots means you just try, but it doesn't work. 4 shots made by a team of basketball. It can be netball as well. So 4 shots, this is the vector. So you got 18, 22, 15, 13, 5, number of 4 shots. Now let's see what will we get. So 4 shots. Okay, since we are going to start a new one, I'm going to remove the things. So this rm list equals ls. This command will erase all the environment variables, and I'm going to refresh the console as well. So my command was 4 shots. So you can see 4 shots, numbers 1 to 5, 18, 22, 15, 13, 5. So you get that. I can use the sum function to total them up. So if I say sum and say whole shot, you can see it's 73. Like let's add them up and see. 18, 22, 15, 13, 5. So it's the same thing. Summing up will add up all these values. Sum variable will give you the sum of all the values there, right? But what if there are what they are read in as strings? So same thing, but instead of numbers, so you can see num here in the variable, you can see num. Okay, so I'm going to change that. Instead of that, I'm going to make them strings. So you can easily do that by double clicking this and then just shift apostrophe this mark, string mark, and look at this number thing. It will be converted to CHR. That means characters. Now it is converted into string, set of strings. Now if I go back and type sum, it will not work because it's CHR. So when you import your data, make sure that you observe this part, particularly either it's a data frame or in the case of variable, check whether it's a number or a character or any other thing. Now, if it is a number, you have it, it will not work. So if I say class, I'm going to say instead of I'm going to say class. So it's a class of character. If I go and type other way around, and if I say what is the class of this, you can see it's a numeric. So that's the difference. If I have apostrophe commas, inverted commas, it will become character. Okay, so we can fix it with as numeric. So when we want to have a strings one converted to numeric, if you want to convert it to numeric, because some of the times you might get them as is. So if I say as the numeric, and then since I have it as strings, I'm just going to say copy paste it. Then you'll get it as numeric. So if I'm still I have it as say, so I'm going to say numeric as numeric. So you can see numeric part becomes converted. So you kind of remove the these inverted commas 18, 18, 22. So try that out. Just take 2-3 minutes and see how it goes. You can follow the steps here in the given in the Moodle. Now you can go with even some. You get the same answer as 73. Right. So next part, I think these are very similar in terms of this. So let's say that I have a numeric case now. I have this numeric foreshot. If I say as character and then type my numeric foreshots, you should be able to see it as numeric as characters. So if I say I want to convert this to character foreshot, then you should get okay, what is the class of this? It will be given as a character. So you can check this CHR here. Character numeric is CHR, foreshots CHR because I convert it into that. Numeric foreshots is NUM. Right. So let's look at this. Just type. Okay, instead of I'll do this way. Now I have character and number together, right? If I say tibble, right? So what will happen to this? So let's look at that. If I say tibble, let's see what will happen. Tibble, instead of names, I'm going to say character foreshots, and I'm saying numeric foreshots. Let's see what will happen. So you have to import this library tibble, or you can, I think it's under dplyr. Don't remember, it should be before you do that tibble command, you have to import the library tibble, tibbl. It creates a kind of an Excel sheet. So you can see character chr here, and then the two values. So it's easy to see when you follow these two commands, because I just created the names and the numbers. So you have these two. So you have something called names. So Mike, Dennis, Sally, and so. And then if I type teams, so you get the team they belong to, right? But if I want to put them in order, like a column, like an Excel sheet, simple Excel kind of a thing, you can just type here name and team. So you can see they will be arranged like a nice table. So if I type question mark table, be able to build a data frame. Tibble constructs a data frame. It is used like base data frame, but with a couple notable differences. The return data frame has the class table data frame in addition to data.frame. It allows so-called tibbles to exhibit some special behavior. Enhanced printing. Tibbles are fully described in this one. You just go and read about it. So when you say question mark the name, you'll get that. Tibble is much lazier than in terms of transforming the user input, blah, blah, blah. You can read about it. So basically, it gives you a very nice data frame. If you go and assign a data frame to that data frame, Tibble, this, you'll get a data frame here, df. So when you click it, you get a nice Excel look kind of a data frame here. So that's the beauty of it. Right. When you do something in R, and then let's say that R requests you to input a data frame, then you should be able to create a data frame, because you know how to use a tibble now. You can use the tibble, convert the data into a data frame, and then do the necessary assignments. For example, select, filter, those things can be applied to data frame. So if you remember select command, so by the way, you have to import dplyr to do the select command. If you remember dplyr, we import it, and then you put select under dplyr. Now df names, you can say names have been selected. So if you go and say teams will be selected. So that's how it works. Basically, if you do that select command just without a data frame, you will not be able to get it, because select works with the dplyr and it works the data frame. You have to convert it to data frame. So if I give you something like x is a numeric something, and then whether this works, it will not work. For example, say numeric foreshots 1, it will not work. So that's what I told you. In the quiz, I may ask something like this. So you should be able to say whether it's working or not by looking at the type of data. So that's the whole point of it, not only for the exam, but also in your day-to-day analysis. You should be able to say whether it's not working or it's working, because when you look at the data code and the type of data and then the operations used there should be. Can you hear me? Hello, hello. Okay, thank you. Right, I was talking about this. Right, so it only works for the data frame. So this is how you convert into data frames using the tibble command. Right. So basically, okay. The next one is assignments. Right now, when you have a data frame, right, that's cool. When you have a data frame, you can type data frame and then $mark. It will give you the column headers. So if I say head and say df, you can see the headers first, basically to give you the things. And if I want to extract some column info, you can say df $mark names. And if I say one, you get the first one. If I say two, you'll get the second one. If I say two, number of dimensions, say one, two, just yeah, because it's just column. So if I say df something like this, df one, two, it will give you what it is. Right. So just try that out. Try these things. See how your data frame can be accessed, how your data frame can be called. Right.